this video, we will see how that particular characteristic of a cryptographic hash does ensure the integrity of a blockchain. So we have previously seen that a blockchain consists of a list of records which have been split up into a number of blocks, and that these blocks are linked together by means of a cryptographic hash. We can now zoom in just a little bit to see exactly what this looks like. So here we have our chain of blocks which makes up the blockchain. And just to simplify the view, we have shown that each of the blocks includes a collection of transactions as well as a hash of the previous block. So you see here that the hash of the first block is one of the contents of the second block in the blockchain. That hash, along with all of the other information within that second block, will be used as input in order to generate the hash of that second block, which in turn becomes one of the pieces of data which is included within the third block. And this chaining goes on for the entire blockchain. The only block in the entire blockchain which does not include a hash of the previous block is the first one, and this is something which is also known as the Genesis block. So with this form of arrangement, you can see exactly why this structure is called a blockchain. You have a sequence of blocks which are essentially chained together by means of having a cryptographic hash of the previous block within them. And the reason for including this cryptographic hash is to ensure the integrity of the blockchain. To understand exactly how that works, let us consider what happens when someone tries to tamper with one of the blocks in the blockchain. In our example, we try to modify the contents of a transaction in the first block, or the Genesis block. Now, the effect of this is that the hash of the first block will be completely different. We have seen previously that even a minor change in the input to a hash function is likely to produce an entirely different output. So even a minor change in the transactions of the first block is likely to produce an entirely different hash. And anyone who is trying to verify this blockchain will immediately notice that the hash produced of the first block is very different from the cryptographic hash of block number 1, which has been included in block number 2. In order to avoid this inconsistency, perhaps the malicious party who has altered the contents of the transactions will modify the second block as well so that it includes the newly computed value of the first block. But then, of course, the hash